Okay, let's apply now our place value understanding to some number pattern work. Okay, we're going to start today with this number here, which is 21,121. If we're going to put this into our place value chart, it's going to look like this. Well, we have 121 over here, 2 tens and 100, that's this part here, and we have 21,000. So that means we've got one single thousand and two 10,000s. 2 tens are 20, so we've got 21,121. Okay, let's say that we want to add 10 to this number. Okay, that might seem pretty straightforward. Let's just go over to here. We're going to first of all make our number up and see what it looks like, and then we're going to start adding and then doing some subtraction. So here we go, we have 2 10,000s, 20. We have one single thousand, so we've got 21,000. Now we've got 100, and now we've got 2 tens, 20, and 1. 21,121. Okay, let's say we want to add 10. And I'm going to draw here a number line. We're going to use quite a lot of number lines with number patterns. So if we're adding 10 to this number, well, let's go over here to our manipulatives again. If we're going to add one more 10, we can see that our answer would be 21,131, because we've now got 3 tens instead of 2 tens. And if we added 10 more, let's go back over to here again. So you can imagine what it's going to be. If we're going to go over, I'm going to add 10 more. So now our new number will be 21,000, still got 100 over here, but now we've got 4 tens and still 1 1. And our next number, 21,151, 21,161, and so on. So we're adding 10 each time. Okay, that's pretty straightforward. We can see on our number line these plus 10 jumps each time. Okay, let's do another one now, but now we're going to do some subtraction. So let's create ourselves a new number line. Here we go here. And again, we're going to start with 21,121. Let's start with the same number. And this time we're going to subtract 10. So again, we're going to go back to the manipulatives over here. Let's get rid of the ones we added. Okay, here we have our starting number. So we still have our starting number, so we have 21,121, but now we're going to subtract 10. So if we subtract 10, what you'll notice is the others stay the same. So we have 21,100, and now we've only got 1 10 and 1 1. Lots of ones there. Then if we take away 10 again, so if we go back to our manipulatives, here we go, we take away 10 again, and now on our number line, here we go, take away another 10. We've still got 21,000, we've still got 100, now we've got 0 tens and 1 1. Now what happens when we take away 10 again? We don't have any more tens. Well, now we need to use our knowledge of place value. Here we go, a moment. Now we do have this 100 here. Now we know 100 is the same as 10 tens. So we can, in fact, take away a 10 from the 100. So there we go. And now we can see the next number in our number pattern would be 21,000, stays the same. But now we've got no hundreds because we had to take a 10 from that 100. But we have got 9 tens and 1 1. And now we can start to take another 10 away. 21,000, no hundreds, and it would be 81. Okay, so let's move on. So here's another example. You might see a question like this. It's already on a number line for you. You can use the manipulatives and braining count to solve it just like I just demonstrated. So the key with number patterns is to notice. So I'm going to ask you this question. What do you notice? We can see on this number line we're subtracting thousands. We can see our numbers here, and we can see there are 2 missing. So I'm going to look at these numbers and tell you what I notice. Well, first of all, I notice that 841 appears in every single one of these numbers, which does make sense because it says taking away 1,000. So if we're taking from the thousands, then that shouldn't be affecting our hundreds, tens and ones, but it will affect our single thousands and maybe our tens of thousands. Let's see. So here we had 36,841, and then we had 38,841. So I'm noticing there's a 2,000 difference between here and here. And yes, I can see that if I took away 1,000 from here to here, it would be 37,841. Now sometimes it's hard to just look where the gaps are. Sometimes it's useful to look where there is a more consistent stream of the numbers. So here you can see the pattern a little bit better. So you've got 43,000 and the hundreds and tens and ones, 42,000 and the hundreds, tens and ones, 41, 40, and we can see our pattern. This one's going to be 39, 38, 36. What's really important is when you think you've got the answer, you check. You can check by going in the direction that you're doing it in or it's expressed in, but you can also go the other way, because while this is subtracting 1,000, if you went in the opposite direction, well, what would you be doing? It should be 1,000 more as you go this way. Does that work? 36,000, 37,000, 38,000, 39,000. Yes, it's working. 41, 40, 41. Okay, let's do a couple of examples. So sometimes you'll get questions like this, which will say, what's 1,000 more than 19,503? So in this case, you know your knowledge of place value. If you're adding into the thousands column, is it going to affect your hundreds, tens and ones? Well, no, it's not, because you're only adding 1,000. Think back to the discs that we used at the beginning. So now instead of 9,000 here, you're going to add an extra 1,000. Well, 9 and 1 would make another 10,000. So you're, instead of 19,000, 1,000 more would be 20,503. Sometimes you'll get questions like this, not quite so straightforward. It's giving you the numbers and then saying, well, this number is something more than this number. So you've got to work out what those jumps are on the number line or what's added to those discs. So we've got 60,000 here and 383. And we've got 60,000 here and 373. Again, you've got to really look and notice. I notice these are the same, the 60,000s. I notice the 300s are the same. I notice the 10s are different, but the 1s are the same. So the difference between 80 here and 70 here, or 8 10s and 7 10s, well, it's a 10 more. This number here is 10 more than this number here. The other way to think about it, to check, I could think, well, if that's true, then this number here is 10 less than this number here, and I can check it by doing it the other way. Okay, let's look at the next example. 49,161 is 100 less than something else. Well, this is 49,161, and this is less than another number on the number line higher up. This is less. In fact, it's 100 less. So if this is 100 less, then obviously the number we started with is 100 more. So we've got 49,261, because I'm adding an extra 100 here. I'm adding an extra 100 to the 100 here. So now I've got 200. So let's double check that, because it says less, but the example I just did it in the other direction. So now we're going to go back and check. Is 49,161 100 less than 49,261? Yes, it is. Okay, 2 more examples. So sometimes you'll get questions like this where you've got a string of numbers and you've got to work out what a missing number is. What do you notice? I notice the digits that stay the same. These are staying the same. I notice the digits, these are staying the same as well, the 10s and 1s, and I'm noticing this is changing. This is the same, 12,085, these 2 bits are the same, but this is changing. The hundreds is changing. So how's the hundreds changing? Well, it was 900, 800, then there was another one, then there was 600, then 5, 4, 300. So I can see it's changing by 100 each time, and our missing number here is the 785. 12,785. Observation is so important, and talking it through talking out loud is also a good idea. Okay, let's have a look at this last example. 66,935. I'm noticing straight away that this is staying the same, 935. So something's happening to our thousands. It's 66, 67, 68, 69,071. Okay, I can see it's going up by 1,000 each time. So after 69,000, it's 70,000. And that fits because then another 1,000 more will be 71. Okay, so there's a few examples. Hopefully that's explained that enough that you can now try some of your own.